Rajshahi, Higher Maths, 2017, question number 5. In question 5, we have 4 different points. They are A, which is p 3p, B, which is p squared 2p, C, which is p minus 2p, and D, which is 1, 1. Now in part A, we have to find the value of p if the line joining the points B and C has slope a half. To solve this, we use the gradient formula. Now the gradient of BC is y2 minus y1 over x2 minus x1. And we have x1 is equal to p squared, y1 equals 2p, x2 equals p minus 2, and y2 equals p. Now if we substitute, we get p minus 2p over p minus 2 minus p squared equals a half. If we cross multiply, we get 2 times p minus 2p equals 1 into p minus 2 minus p squared. Now the p minus 2p cancels to minus p, so on the left hand side we have minus 2p, and on the right hand side we have p minus 2 minus p squared. Now if we add p squared to both sides, subtract p and add 2, we end up with p squared minus 3p plus 2 equals 0. Now we can factorize this. We want two numbers that add to minus 3 and multiply to make plus 2. They are minus 1 and minus 2. So the expression factorizes as p minus 1 times p minus 2 equals 0. Now, if two things multiply together to make 0, then one of them must be 0. So either p minus 1 is 0 or p minus 2 is 0, which tells us that p is 1 or p is 2. And that's our answer for the first part. In part B, we're asked if the lines AB and CD are parallel, find the admissible value of p. In part B, we're going to use the same gradient formula as we did before. So we have the gradient of AB is 2p minus 3p over p squared minus p. And the gradient of CD can be shown to be p minus 1 over p minus 2 minus 1. Now, if AB is parallel to CD, those two expressions are equal. So we have 2p minus 3p over p squared minus p equals p minus 1 over p minus 2 minus 1. Now we can simplify those. On the left-hand side on the top, 2p minus 3p is minus 1p, and on the bottom we can factorize it as p into p minus 1. On the right-hand side we can just leave out the brackets around p minus 2. So we end up with minus 1p over p into p minus 1 is equal to p minus 1 over p minus 2 minus 1. Now the p's cancel on the left-hand side, so we're left with minus 1 over p minus 1 equals p minus 1 over p minus 3. If we cross multiply, we end up with minus 1 times p minus 3 equals the bracket p minus 1 all squared. Expanding the brackets gives us 3 minus p equals p squared minus 2p plus 1. If we subtract 3 and add p onto both sides, we get 0 equals p squared minus p minus 2. Or just swapping the sides, p squared minus p minus 2 equals 0. Now the left-hand side factorizes. We want two numbers that add to make minus 1 and multiply to make minus 2. That's minus 2 and plus 1. So it factorizes as p minus 2 into p plus 1 equals 0. So one of those must be 0. Either p minus 2 is 0 or p plus 1 is 0, which gives us p is equal to 2 or p is equal to minus 1. And that's the second part done. In part C, using the negative value of p from part B, the straight line joining the middle points of the non-parallel sides R and S of a trapezium ABCD prove, with the help of vectors, that RS is parallel to AB and also parallel to CD, and the length of RS is half the length of AB plus the length of CD. Now to solve this, we have P equals -1, and the points then become A -1 minus 3, B 1 minus 2, C -3 minus 2, and D 1, 1. It's a good idea to draw a diagram. We can mark in the points A, B, C and D and draw in the sides. Then let the position vectors of the points A, B, C and D be the vectors A, B, C and D. Now R and S are the midpoints of AC and BD, so we can mark them in on the diagram and draw the line RS. Now the position vector of R is OR, where O is the origin. And we have going from O to R is the same as going from O to A and then A to R. So OR equals OA plus AR. But AR is half of AC, so OR equals OA plus a half of AC. But AC equals AO plus OC, or OC minus OA. So OR is equal to OA plus a half of OC minus OA. OR is equal to OA plus a half OC minus a half OA, and that simplifies down to a half into OA plus OC. Now, as vectors, that can be written OR is equal to a half of A plus C. Similarly, we can find the position vector of S. OS is equal to a half B plus D. Now, going from R to S is the same as going from R to O and then O to S. So RS is equal to RO plus OS. So RS is equal to OS minus OR, because RO is minus OR. So RS is a half B plus D minus a half A plus C. Well, putting that into a common bracket, RS is equal to a half B plus D minus A minus C. Or we can divide that up as RS equals a half into B minus A plus a half into D minus C. But B minus A is AB and D minus C is CD, so RS is equal to a half AB plus a half CD. But AB is parallel to CD, we know that from part 2, so that means AB is a constant K times CD, which means RS is equal to a half KCD plus a half CD, which is a half K plus a half all times CD. So that means the vector RS is a constant times the vector CD, which means they're parallel. So RS is parallel to CD, but we know CD is parallel to AB, so RS is parallel to AB, which is also parallel to CD. Now, because AB is parallel to CD, that means the length of AB plus the length of CD is equal to the length of the vector AB plus CD. Now RS is equal to a half into the vectors AB plus CD, so RS is equal to a half the lengths AB plus CD.